Hello everyone. Let's start this webinar now. We welcome you all for this interesting webinar on the LTE testing tools. My name is Sanjeev and I have my colleague Savita who joins me in presenting this webinar. As you all know that wireless communications have evolved from the second generation systems of the early 90s, which first introduced the digital cellular technology, through to the third generation systems with a higher data bandwidth, and now the much anticipated fourth generation technology being developed and deployed today. So the fourth generation wireless technology, which is the 4G and also commonly referred to as LTE, which is long-term evolution, is being developed aggressively, and it is slowly replacing the older technologies. This is mainly because of some of the key features it provides, like the very high data rates, flexibility of using the existing and new frequency bands, and adding low-cost services with better user experience, and most importantly, reduce the network operators' cost considerably. So, because of these key features, many mobile service providers are deploying their 4G services all over the world. But at the same time, they are facing a lot of challenges in testing each of these LTE interfaces before they actually deploy it to the real world. This is where our LTE test tools would be useful. Over the last couple of years, we have developed various emulators and analyzers for testing the LTE network. Today, in this webinar, we'll be providing you an insight into these LTE test tools, and we hope that this information will help you in marketing our LTE test tools. Now, let me ask my colleague Savita to take control and proceed with the rest of the presentation. Savita.
To start with, we'll have a small introduction of LTE network, and then we'll go into the solutions provided by test solutions provided by GF. As Sanjeev has explained, LTE is a fourth generation technology which has emerged or evolved from a 3G because of rapid increase in usage of mobile data and very new applications emerging in the market, like online gaming, mobile TV, broadband broadcast TV channels. So because of these very huge usage of mobile data, LTE has emerged. This is a simple network architecture of LTE, where you can see LTE is having a huge bandwidth with a variable width channel, which will allow to support different mobile communication devices as shown in the screen. So here all the mobile equipments are communicating with eNode B and evolved packet core to provide our services. So in this picture we can know, it will show it is at the same time it is also backward compatible with the GSM and UMTS. So with this introduction, we'll go with the LTE test solutions. So why we need LTE? Because of everything is moving towards IP infrastructure. So because of this, you can see in the picture there are many applications coming, like online gaming, IP messengers. So these all requires a very huge data rate, and actually at the same time it is equally important to have a good quality of the services. So LTE is the solution for all these things. So coming to the network architecture, this is the network architecture of LTE, which contains EUTRON and EPC. EPC is evolved packet core. This is specially designed, LTE is specially designed to support packet data. So from in the screen you can see eUtron contains eNode B, which is a base station similar to a GSM. If you are familiar with a GSM network, it provides air interface to a mobile, and on the network core network side it contains MME, serving gateway, PDN gateway. MME is the entity which will provide mobility services, security functions, bearer functions to the mobile. Serving gateway is the entity which will just route the data from base station to PDN gateway or PDN gateway to base station. That is eNode B. PDN gateway is the entity which is going to connect to the external world, that is internet. So these are the important modules involved in the LTE architecture, LTE network. So GL supports X2, S1 AP, S6A, S5, S8 or S11 interfaces. The respective protocol stack is shown. So the products support which supports these interfaces are listed here. MAPS LTE X2 AP emulator is used to simulate a X2 interface which is between two eNode Bs. It is most likely a handover procedures between two eNode Bs. Then a S1 AP emulator, that is MAPS LTE S1 emulator PKS140, which is used to simulate S1 AP interface between eNode B and MME. S6A can be simulated using MAPS diameter emulator, which is PKS139. It is between MME and HSS. S5, S8, S11 interfaces are between MME serving gateway and serving gateway to PDN gateway respectively. The product used to simulate these interfaces are MAPS LTE EGTP emulator, that is PKS142. These are the products which are used to test LTE interfaces, simulate LTE interfaces. So to start with the solutions, GL provides a complete lab setup. As you can see in the screen, all the interfaces on the core network side is simulated by a GL. That is either S1 AP, S6A, S11, S5, S8. All these interfaces are simulated by GL. Then a real eNode B is used here, which can be connected to a mobile. So a mobile testing can be carried out here, or user can replace a real eNode B with the DUT, device under test, and they can test eNode B. This is another setup where a real eNode B is replaced with a simulated eNode B. The advantage of using the simulated eNode B is user can have thousands of UVs simulated here. As it is very difficult in the lab situations where we cannot have so many UVs connected to the node B, or it is difficult in the real time. So in that case, GL's MAPS eNode B will provide a facility to simulate thousands of UVs against a core network.
Does anyone have any questions till now?
Yeah.
Just raise a query. Yeah, you may continue.
Yeah, we need to study what XCR supports, but as far as our tools concerned, we are going to support almost all the scenarios, and even we have a load testing also possible. Load testing is possible. One limitation we are having is user plane traffic simulation. We are currently we are supporting only HTTP and mobile IP core traffic simulation. Apart from that, there are other protocols needs to be simulated like FTP. Those things which has we are working on that, and it may we may get these things in future. Apart from that, we need to understand what XCI is providing, and based on that we can provide our advantages and disadvantages. Per box means per eNode B we can simulate up to 5,000 simultaneous UVs. At the rate of 500 calls per second. It's 5,000 simultaneous UVs can be simulated using a eNode B. Any questions? Okay, we'll move next. There are many ways to use the LTE tool. Few of the scenarios have been listed here. It can be, we'll go one by one. As you have seen in the previous slides, we can support a lab setup. At the same time, we can have a single interface simulation also. For example, eNode B and MME, that is only S1 interface can be simulated between eNode B and MME, or MME HSS to simulate S6A interface, or MME and SGW can be simulate S11 interface. S5 S8 interface is used to simulate SGW and PDN gateway. These are the interfaces which can be supported individually or in group to have a lab setup. Either ways is possible. Next we'll go to different ways of testing. We'll see how it can be used in different ways. So there are possibilities where even we have a single interface and we need to simulate a complete network functions. In that case, MME, a single interface MME can also simulate HSS, EIR, AUC functions. In this case, all these modules are included or embedded within the MME. So a single interface simulation is also very good, which can support network functions, other network functions. So here, as you can see in the screen, HSS, AUC, EIR, SGW are embedded within this MME without having a real HSS or those entities. We can have embedded within the MME. This is the advantage of single interface simulation. Multi-interface simulation. In multi-interface simulation, we can connect real equipment to a MME. As shown in the screen, MME can talk to multiple devices at the same time. Here, EUT will be EIR or HSS or SGW or PGW. So, MME can talk to all these devices in case of multi-interface simulation. A wraparound testing is also there, which is helpful in the lab testing scenarios where all the entities are simulated by the GL apart from the DUT. So traffic can be routed back to the GL test tool, and it can be analyzed for the validity testing or conformance testing. Currently, conformance testing is not supported, but we are working on that. I will get back to you with regarding this after discussing with our manager. But the existing tool will support all the scenarios what the conformance test cases covers, but those has to be manually tested. So conformance test suite is not yet available. Yes, since this is Maps is completely script-based application, user can have conformance scripts to test their duties. It gives that complete flexibility to do a conformance testing, and even GL can also help in coming up this scripts for conformance scripts. So the basic procedures supported in LTE are all the basic procedures like attach, detach, authentication, security, ciphering. All these procedures are supported along with the installation. Also, it supports the handover procedures, CS fallback, and voice over LTE. These are the important features which are supported with the LTE tool. This is a typical call flow where the LTE call is achieved from end-to-end call between UV to PDN gateway, how the context is going to be established, how the authentication or RAB assignment procedures are established between eNode B, MME, HSS, SGW and PGW. So this is what we are going to simulate with our application. And here you can see UV is generating these calls. So Maps allows the configuration of UVs. So user can have a multiple UVs simulation. So for that there will be a subscriber configurations. So this is the window where user can configure a multiple UVs. And this is a message editor where user can create messages as per the requirement. This is very helpful in conformance, creating the test cases for conformance, which will allow the user to select any of the information elements required for that particular test case. In this way, it is very helpful application. And this is different call generator of different applications. This is how actually Maps looks. Here user can generate or receive a calls, and you can see all the interfaces share a common GUI. So the network, framework architecture remains same across all the applications. So which will help the user to get familiar with the applications very easily. If the user is familiar with one application, it is easy to, there is no extra effort required to understand other applications also, irrespective of the protocols. And this is User plane traffic simulation. This is the example we are showing how we are simulating a HTTP traffic. There will be a tunnel established between serving gateway and eNode B. So user can, once the tunnel is established, on the established tunnel, user can transmit or receive HTTP traffic. User can, when the real eNode B is connected, user can actually browse through data. He can use real HTTP traffic there. And during the simulated eNode B traffic simulation, simulated eNode B, user can have a HTTP traffic simulation offline. That is, we'll have some pre-recorded HTTP files which will be played back using on the established GTP tunnels. This is the example how the GTP HTTP traffic is carried out on GTP tunnels. So user can have a multiple tunnels, and user can have a concurrent traffic transmission or sequential traffic transmissions, or traffic can be transmitted only once. So this is an example how to simulate HTTP traffic. Next is, these are the few of the added features provided with the Maps application. This is a load generation screen you are seeing. Here user can, as I have told you, it can support up to 5,000 simultaneous calls. This is the window where you are going to simulate load, and the load can be distributed across different patterns. User will be having an option to select a different patterns like step, sawtooth, ramp, like that, and based on that, a calls will be placed at the specified rate till the maximum calls are achieved. And there will be a statistics view which will help the user to analyze the traffic. We provide a pie chart and a graphical representation of the calls, at what rate the calls are being pumped, and at what rate the calls are achieved with the application. Here user can also come to know the failure call rate and pass call rate. So out of completed total calls, what are the completed calls, passed calls and failed calls? Such statistics is also available here. Along with this, transmitted the message count and received message count is also available. Along with that, retransmission count is also there. If any message is retransmitted, that count is also displayed here. So in analysis, we support all the interfaces of LTE network. The picture shows wherever the GL supports the analysis capabilities. And this is the view of protocol analyzer, LTE protocol analyzer. It is having 3 different panes where the summary columns, then a detail view and CDR view. CDR view will give you call related information. So all the messages of particular call is grouped together and can be displayed. So user can select any of the call and he can analyze the analyze on the basis of calls. And in the detail view, it gives details of every layer of that protocol. If you take an example of S1 layer, S1 AP interface, then all the layers of S1 AP from IP to S1 AP layer, NAS layer, all the messages and all the information is decoded and it can be displayed, which will help to analyze what has been gone wrong in the real time. This is how the voice over LTE traffic is analyzed using the protocol analyzers. At the same time, we support a simulation also. This is one capture which shows a voice over LTE. You can see a SIP message is enclosed within the GTP frame, GTP packet. So SIP is carried over GTP. This is analysis of voice over LTE call using packet scan or using LTE analyzer.
Okay, good. Good job, Savita. With this, we come to an end of this webinar. Thank you, everyone, and we hope to see you once again in the next webinar. Thanks a lot.
Yeah, thank you all.